So like I was saying, you made it to what? Well, you've basically made it to the end of this course.
Oh. What?
I have taught you everything that you need to know for Math 10.
Wow.
And some of you may be saying, Mr. Greenlaw, why are we learning 9.3 then? Good question, Jasmine.
I didn't know you sounded like that.
The reason why there's one more section is because today you'll be comparing all of the methods for solving systems of linear equations that you've learned. What are the 3 methods you've learned for solving systems of linear equations? Substitution, elimination, and graphing. Okay? So what you're going to be doing today is just comparing the efficiency and the usefulness of those 3 methods in this section.
What?
Okay? So, hopefully in doing so you'll develop a feel or an intuition for when you should use the different methods. You can use any method for any system, but sometimes it's more productive to use one rather than the other. So let's get right to it. Jeremy and Samantha participated in their school's Plantathon fundraiser.
What a bunch of hippies.
Jeremy started planting seedlings at 10 in the morning. Jeremy plants 1 tree per minute. Samantha started planting at 11:30.
Slacker.
Why it took her an hour and a half later to start, we don't know. She was doing her hair. Yeah. Her planting rate was 3 trees every 2 minutes. Is she going faster or slower?
Yeah, faster.
She's going a little faster.
That's like 1.5.
At what time had they planted the same number of trees? Use the system of linear equations to figure this out. So what we're going to do for this problem is we're going to create a model that represents Jeremy's planting abilities and another model for Samantha's planting abilities. Okay? So n, the number of trees that they plant, for Jeremy in this case, is equal to what? How have your modeling or equation building skills developed thus far?
Can you
So
just
for
add the amount of trees that...
Yeah.
Okay.
that Jeremy would have planted in that time. So
How many trees is that?
I guess if we start our experiment, or if we set up our system so we're going to start counting how many trees they have planted so far from the time Samantha started, we would need to take into account how many trees Jeremy has planted thus far.
So it's 9 plus 9.
Okay. That makes more sense. So he's 90 trees ahead of her. Plus 1 tree per minute. And then Samantha will just be 1.5 t. That makes more sense. Good job. Okay, solving by graphing. We should get a more reasonable solution here.
I hate Windows settings.
Okay, so if you forget how to do this, y1 is x plus 90. Y2 is 1.5x. And then to find the intersection, second trace 5, enter, enter, enter. Okay, so the solution was, those of you who found it,
180 and 270.
180, 270.
Cool.
So after 180 minutes, they've both planted 270 trees.
That's a lot of trees, man.
Okay? Same thing now, just with an algebraic method. Okay? So, let's see here. Our two systems were n equals t plus 90 and n equals 1.5t. Should we use elimination or substitution?
You can do this either.
Substitution.
Substitution? Why?
Because one is solvable.
It's a good reason. Yeah. N up here is solved for. Usually that's a convenient time to use substitution. Okay? So let's do that. I'm going to take this expression and substitute it in for the other n right here. Okay, so that will give t plus 90 equals 1.5t. And then solving for t, we're bringing over this guy. So we have 90 equals 1.5t minus t, which is 0.5t. And if we divide both sides by 0.5, we should get 180, just like we did last time. Therefore, n should be, once we find it, 270, right? So I'm going to put t for equal to 180 in for this t up here. So that's n equals 180 plus 90. And lo and behold, the algebra holds.